Okay, so on Friday, I promised that I would go through, I would post a video on how to do day 10, number 2, which is the farmer with the silo, just to make sure everybody got a chance to see that one again. So that's what we're doing right now. So Farmer Bob has 2,000 square feet of sheet metal from which he is going to build his grain silo. It's going to be a traditional shape with a cylinder for the sides and then a half sphere on top. So the first thing it says is to write the formula areas for the surface area and volume of the silo, period. So I'm going to move this aside and let's go talk about our formulas. So first of all, let's kind of draw our shape out a little bit here. So this is what we're kind of talking about here, this kind of a shape. So up here on the top, we have a half sphere. And over here, we have a cylinder. So we're going to start with our half sphere up here. I'm going to do the volume first. So volume, because it's half a sphere, you're going to write 1/2, followed by the volume formula, which is 4/3 pi r cubed. You'll then want to simplify that. So I'm going to get rid of that. So I'll end up with 2/3 pi r cubed for the volume of my half sphere. Now let's talk surface area. So again, we have half a sphere, so I'm going to put it times 1/2, followed by the formula for the surface area of a sphere, which is 4 pi r squared. So that simplifies to 2 pi r squared. Now again, if you need more time, you just hit the pause button. You can write down your formulas. Now let's move on to the cylinder. So I'm going to start with the volume. So the volume of any prismatic cylinder shape is always going to be base times height. And my base in this case is a circle. So I'll have pi r squared times h. Now let's talk about the surface area. Now we are not including the circle at the top and the bottom, because we're not going to make those out of sheet metal. So I only want the main part of the cylinder. So the main part of the cylinder, of course, has a height. But if you think about the shape of it, that is the circumference of a circle. So I will have 2 pi r h. So there's my surface area for the cylinder, not including the bottom part where I'm not going to put sheet metal, or the top part up here because it's already got its own lid, so it doesn't need another lid. This is not like a Coke can. All right, now let's return to our directions. The directions say write the formulas for the surface area and volume of the silo. Okay, so let's put those together. I'm going to scoot it up. So if I want the volume of the silo, I'm going to have a half sphere plus the cylinder. If I want the surface area, I'm going to have the half sphere plus the cylinder. So those are my two formulas that I put together using those. Let me slide it up just a little bit. Now let's go on to the next sentence. The next sentence says combine these formulas so that you have one volume formula based only on the radius of the silo, not the height also. Okay, so what they want me to do is to solve for the height down here at the end, and then they want me to substitute that into that formula. So let's solve for the height. So first thing I'm going to do is take my surface area and subtract 2. Oh, I'm missing an R here. Some of y'all probably were screaming that earlier. And I just now saw it, so it's fixed. And that equals 2 pi RH. And then I'm going to divide my 2 pi R to the other side. So on this side, I have the height. On this side, I have surface area minus 2 pi R squared over 2 pi R. Okay, so I need to put my surface area in because right now, even though I've solved it for age, I still have a surface area and a radius. Now, fortunately, in the problem, they told me there were going to be 2,000 square feet of sheet metal available. So I'm going to replace that SA or surface area with the 2,000 square feet. And then I'm going to simplify this fraction. Now, I'm sorry, folks, you can't divide the pi and the r out because unfortunately that 2 pi r is also under the 2,000. But I can divide 2, 2, and 2. So I will. All right, so now that I know what the height is or what it's solved for, I'm now going to take this entire piece and I'm going to put it right in there. So let's do that. Okay, so I have 2/3 pi r cubed plus pi r squared. And I'm just bringing all of that up. So the 1,000 minus pi r squared over pi r. So I get to there. So technically this is times pi r squared and this is divided by pi r. So I can cross divide these out. And there's 2 r's here and 1 there. So I'm just going to grab one of the r's. So we get to 2/3 pi r cubed plus r times 1,000. Okay, so at this point, you can stop here and then go put all of this into your graphing calculator. I'll just write GC graphing calculator. Or if you'd like, you can distribute the r and then go put it in your graphing calculator. So what are you looking for in your graphing calculator? You are looking for the top of the curve. So if you go to your graphing calculator, and I don't have mine in front of me right now, but if you go to your graphing calculator, down here on the bottom, you're going to have your radius. And then over here on the side, you're going to have your volume. And it's going to make a curve, something like this, that you're going to see. And right up here, that value right there is going to give you the radius, comma, the volume, that will maximize the volume and give you the best possible shape. So again, I would put this into my graphing calculator, and then we would kind of go from there. Now, let's talk about like a feasible region. So we know that our volume can get kind of big on something like this, but and maybe if I want to get a little crazy with it, I might say, okay, I'm just going to set this for like 20,000. But let's talk about your radius here. Remember, number of feet that you possibly could make this thing. I would probably start with something like, if I'm just kind of guessing, I would start and see what 20 looked like. And if 20 is like way over here on the side of your graph, maybe cut it down to 10. But try and resize it a little bit, play around with it. Same thing, if this is like way off the mark, the 20,000, it's like just crazy too big, cut it down, make it 2,000 until you get to a feasible region. Ideally, the best region is going to be if you can approximate this R. So most of the time you can, because you can count the little tick marks on the bottom over, and you can approximate this. I can't remember, maybe it's 6 feet, maybe it's 7 feet, maybe it's 10, I'm not sure. But, that way you have a decent domain. How far should you go for range? You could go a little bit above this, so like if, maybe this is like, and again, I'm just kind of making up a number here because I don't have my graphing calculator. Let's say that this was 10,200. I might make that 11,000. But that's really all there is to that problem using your graphing calculator. And that will help you find all the stuff you need. So hopefully that helps those of you who are having a little trouble getting through the algebra.